We ended the last video doing problem number 4, which was simply a mole ratio problem. You started out with 13 moles of aluminum oxide, then it asked how many moles of aluminum. Because there's a 2 to 4 ratio, you essentially ended up doubling the original amount, 13 times 4 divided by 2, to get 26 moles of aluminum. That's a mole to mole problem. Every problem that we do is going to have this step in it. It's a matter of whether there's other steps attached onto that or not, how many on each side. And I'll show you an example of those in this video. So how many moles of oxygen will be produced by decomposing 28 grams of aluminum oxide? So in this case, we're given 28 grams of aluminum oxide. So it gives us 28 grams. And it says how many moles. So I'm going to put question mark moles over here. I actually like to write things like this up here because it helps me keep track. Now, the trick to this, though, is that this ratio, 2 to 3, is a mole ratio. It is a mole ratio. That's the key here. I can only go from aluminum to oxygen using this mole ratio. So this grams, what do I got to do with this grams? First is I've got to convert it to moles. I've got to go from grams to moles, then I can do the mole to mole ratio. So what it's going to end up looking like is I got to go grams to moles of aluminum oxide, then I go to moles of O2. So these two things are going to be Al2O3, and then I'll convert to moles of oxygen. So to start with, I'm going to take 28 grams of Al2O3. I'm going to bring grams of Al2O3 down. Now I said I had to go from grams to moles, so I'm going to go moles of Al2O3. Let's keep on going here. Let's bring moles of Al2O3 down, aluminum oxide, and this is where I need to go to moles of oxygen. So this step right here is exactly like what we did up here. But in order to do this, I have to get to moles first, so that's what the first step's for. So it's just adding one extra little step. You already know how to do this step, how to go from grams to moles. That's a mole conversion. And then the next step is a mole ratio, which is a new step for you. Now, whenever you have mole above mole, you go up to the balanced equation. There's a 2 in front of Al2O3. There's a 3 in front of O2. So you go to the balanced equations to get those numbers when there's a mole above mole. When mole is with grams, it automatically gets 1. It's the same as it's always been. The mole automatically gets 1 if it's with a gram. Now, what goes on the bottom? The bottom is how many grams are in 1 mole of this compound, which is a molar mass problem, which I don't currently have ready on hand, so I'm going to pause the video and solve that for you. There we go. To save time, I went and got a periodic table. I went ahead and wrote all this down for you. So if you add up the molar mass of aluminum oxide, and I know that I had to do aluminum oxide's molar mass because if you look, aluminum oxide is the compound in this step. So 1 mole of aluminum oxide has a mass of 101.961 grams per mole. So now what I do is I take 28, because this is on bottom, I divide. So 28 divided by 101.961, and then I multiply it by 3 because the 3 is on top, and divide by 2 because that is on bottom. What I end up getting is 0.4119222 is what my calculator gives me, but I can only go to 2 sig figs, so it's 0.41 moles O2 is my final answer. So just to recap, 28 divided by this, times this, divided by this. Or if you want, you could go this, times this, divided by this, divided by this. The order doesn't really matter. So we'll keep doing a few more examples here. So how many grams of O2 are needed to burn 3 moles of methane? So the first thing we've got to do is balance the equation, as always. To balance this, I need to double this, because I've got 4 on the other side. 2 times 1 is 2, plus 2 is 4, so I need to double this. So we've got a 1 to 2 to 1 to 2 ratio here, mole ratio. Now, like I always do here, how many grams of O2? So it's asking for question mark grams. How many grams of oxygen are needed to burn 3 moles of methane? So it gives me 3 moles of this. It says how many grams are needed to burn that. So when these react, they react in a 1 to 2 mole ratio. So I know already that if I have 3 moles of this, I'm going to need 6 moles of this because it's double. This is a 1, this is a 2, this is a 1 to 2 ratio. So 3 moles of this will require 6. I still want you to show your work. You can't skip steps that quick and easy. But just to kind of give you more of a practical way to look at this, you have to show your work, but I still want you to be able to reason through the problems. So let's take a look at that. I know I'm going to need double the moles, so I'm going to need 6 moles. Now at this point, would you be able to convert from 6 moles to grams of oxygen? And you should be able to say, yeah, I know how to go from moles to grams. I just multiply by the molar mass. So that's all we're going to be doing here. So let's set this up. 3 moles of methane, CH4. Now, because I'm already at moles, I can go from moles of any substance to moles of any other substance. So I always take the unit that's in the top left, bring it down, CH4, and I go to moles of oxygen. Moles of oxygen. So I can go straight from moles of anything to moles of anything else. Now I take this unit down, moles of O2, and I go grams of O2, because it asks for how many grams of O2, right? Whenever mole is with grams, it automatically gets the 1. Whenever mole is above mole, though, that's where I go up here and look at these ratios. So it's 1 mole of CH4, 2 moles of oxygen. So this is where 3 times 2 equals 6 comes in. So we've already solved for that. Then to go from moles to grams, I need to multiply by the molar mass of O2. So you take the molar mass of oxygen, which is 15.999, multiply it by 2, 31.998 is the molar mass of oxygen. Now because all the numbers are on top, I just simply multiply straight across. So 3 times 2 times 31.998, and I get 191. So I end up getting 191.988. So I've got to round to 3 sig figs, so I chop her off there, chop it off. Then this definitely makes that round up. So I go 192, and then my units are always on the end here, grams of O2. So 192 grams of oxygen, because moles of CH4 cancel out, moles of O2 cancel out, and I am left with grams of O2. So I know that it takes 192 grams of oxygen to react with 3 moles of methane. Here's another one. We've got 2 more examples. I would recommend pausing this and trying to do it on your own. Okay, hopefully you gave it a shot, because I find that until you do on yourself and find out where you get stuck, it's easy to watch me and be like, oh yeah, I know how to do this. And then when you do it, you realize you get stuck. But if you can figure out where you're getting stuck, now I can show you. So if you haven't paused it, do that and then come back. How many grams of CH4, so it's asking grams of this, question mark grams, are needed to burn 3 moles of oxygen? So it's pretty much the opposite. We started with 3 moles of this, and then how many grams of this? Now I got 3 moles of this, how many grams of this? The answer is not going to be the same because we're going backwards in the mole ratio, and the molar mass of methane is not the same as the molar mass of oxygen. So we do have to solve this. So we're going to take 3 moles O2, that's what we're given. Always take what you're given and the compound. Then you take this, bring it down, whatever units are there. Then you can go, if you're at moles, you can go to moles of something else, CH4. Then from there we go moles of CH4 to grams of CH4. The mole gets the 1 when it's with grams, but when mole is with mole, that's where we put the ratio from the coefficients in. Again, now we're dividing by 2, not multiplying by 2, because we're going the opposite direction. Then CH4, it's 12.011, 1.007 times 4. Let's see here. This would be 4.028 plus, I better just do this in my calculator so that I don't make a mistake here and have to redo the whole video. Plus 4.028, 16.039. Okay, so now at this point I've got everything set up. 3 divided by 2 times 16.039, and I get to 3 sig figs 24.1 grams of methane. 24.1 grams of methane. Now this is the longest problem you can do because you're starting with grams and you're ending with grams. So let's lay out what we've got here. We've got 15.5 grams of methane. 15.5 grams of methane. And it says how many grams of CO2? So question mark grams of CO2. Now, excuse me, here's the trick with this, is that there's always going to be a conversion. To get from this to this, we need the mole ratio, right? If you're going from moles to moles, it's super easy. It's one step, just like the very first problem, or the last problem of the last video, of the previous video. But in order to do this mole ratio, we have to be in moles. Well, I'm in grams here, so I have to convert from grams to moles, right? So the very first step is going to be from grams to moles. Then once I have moles, then I can jump to moles of this. And then once I have moles of this, then I can go from grams of this to moles of this. Or sorry, moles of this, yeah, is that what I said? Moles of this to grams. So it's grams to moles to moles to grams is how this problem will be set up. In order to do the mole ratio, I have to first get to moles, and then after I get to moles of this, then I have to go to grams. So I'm going to set this up here. Start with what we're given, 15.5 grams. CH4, bring grams of CH4 down. Let's go moles of CH4. Mole is with grams, so it gets a 1. Now, how many grams are in 1 mole? It was like 16. I'm going off of memory here. I think it was 16.039. If it's slightly wrong, it's not the biggest deal. Then I bring moles of CH4 down. Moles of CH4 down. And I need to get to moles of CO2. Moles of CO2. At this point, it's a 1-to-1 ratio. So sometimes the mole will still get the 1. It's just not automatic anymore. Then I go moles of CO2 down. You just keep taking whatever units on the top here and bringing it down if you're not where you need to be yet. Then you go grams of CO2. Because mole is with grams, it automatically gets a 1. The molar mass of CO2, it's 31.998 plus 12 for carbon. So let's just say 32 plus 12. I'm going to round that to 44 just for the sake of this video. When you do these, make sure you round them out a little more. But I am running out of time. At this point, you're going to take 15.5 divided by 16.039 times 44 equals, and then to 3 sig figs you get 42.5 grams of CO2. So this is the biggest stoichiometry problem you can do. If X amount of grams goes in, how many grams of something else comes out? So if you can solve this, you are good to go. Otherwise, we will keep practicing these in class, and there will be lots of opportunities to practice, so take advantage of it.